Assalamu alaikum everyone. Today we are going to conduct lecture number 15 of this online course, and today's topic is addressing mode. We have already covered first part of this lecture, addressing mode 1, in which we have covered two different types of addressing mode. So in this lecture we are trying to complete this topic. Let's proceed to the topic. Okay, before proceeding towards actual topic, which is memory operand addressing mode, let's review some details we learned in last lecture. We learned that addressing mode is basically referring towards different ways in which processor can actually process different data, which we call operand. So addressing mode is collection of different ways in which processor can process operands. We learned there were three types of addressing modes: register operand addressing mode, immediate operand addressing mode. We covered both of them in the last lecture, and today we are going to deal with third type, which is memory operand addressing mode. Okay, let's start our topic, which is memory operand addressing mode. Word operand is missing here, so in we can also call memory addressing mode, but its actual name is memory operand addressing mode. So in memory operand addressing mode, one of the operands should be memory location. That means one data should come from a memory location. And whenever we are considering a single memory location, then we know that we need to calculate its physical address, because memory location is pointed by a logical address through microprocessor, and once microprocessor is interested to fetch or store certain information in any of memory location, then microprocessor must calculate its physical address. So physical address must be calculated, and that physical address will be calculated using this formula: physical address is equal to segment base address colon effective address. This is the same formula that we learned in physical address calculation. One thing we change, one thing we see different here. This is same physical address, this is segment based address, this is same, and after colon we see effective address. Last time it was basically offset, if you remember. So earlier when we discussed this formula, instead of this EA, it was offset. So offset is more or less similar thing, which is effective address, and we gonna explain it in more detail. So segment based address is normally comes from data segment. We know that we are considering data or operand, so data will be stored normally in data segments. So segment based address will be the content of data segment register. Effective address, as I explained you, that effective address can be calculated in many ways, so we are going to see in different slide. By default, data segment register is used for accessing data from memory unless we define another segment. We have already learned while we did cover about segmentation that data segment can be is just one of the segment. There are some other segments like extra segment, stake segment, in which we can store data. So data, instead of data segment register, we can use those segments memory location as well, but in that case those segments must be defined, and that we call segment prefix override, and we are going to learn about it as well. Okay, in this slide we are going to discuss about effective address. I told you that in physical address formula we have replaced this effective address on in place of offset. So what this effective address? Effective address is just summation of three different things: base plus index plus displacement. So these three options will be added to calculate effective address. And what is this base? This base register, base value is basically content of either BX register, which is base register, or base pointer register. So any of these two register will be providing us content for base part. Similarly, index is the content coming from either source index register or destination index register. I hope you remember these are internal register. We covered them. So these two register can provide the value of index register or index value. The third part is displacement, and displacement is just a number which can be of 8-bit or 16-bit. So effective address will be calculated using base, which can come from BX or base pointer register, plus index, which can come from source index and destination index, and plus displacement, 8-bit or 16-bit. One thing which is supposed to be noted here, that it is not necessary that all of these elements, which are base, index and displacement, should present at a time. So it may happen that only base value is given and these two values are not known, so effective address will be just equal to base address. Or it may also happen that we know base and displacement and index is not known, so effective address will be a combination of base plus displacement, and we will ignore this index part. So that means these elements are always not present. That means only few of these values can actually calculate effective address. Okay, as I explained you, there are different ways of specifying offset or effective address. This offset can be actually replaced by effective address. So based upon these, memory operand addressing mode is classified into these categories. So memory operand addressing mode can be direct memory addressing mode, it can be register indirect addressing mode, it can be based addressing mode, it can be indexed addressing mode, or it can be based indexed addressing mode. So all of these are basically 5 different categories of memory operand addressing mode, but one thing is common among them, that one of the operands should be memory location. So we're gonna see them in detail one by one. Okay, let's start our discussion with direct memory addressing mode. So effective address is specified directly in the instruction. There is no need to look for anything, or any calculation is not required. Whatever the effective address, it will be directly given inside the instruction. For example, this instruction says move, MOV move. This is our what that we call mnemonic. PX, this is our destination operand, and that is a register. And look, it is not a register, it is not an immediate value. Remember, when we were using immediate value, we never use these brackets around that data. So that whenever one is going to use this bracket, so this bracket indicates which bracket? This bracket. This is square bracket is basically referring towards memory. So whenever you see these square brackets, you must know that we are talking about a memory. So 5062, it is not a base register. We know that base register can come up either from BX or base pointer, right? Similarly, it is not source index or destination index, so it is not index part, but it is a number, and it is a number of 16 bits. So that is basically our direct displacement, or one can say it is our effective address directly given. So source operand is memory location, as we can clearly see here, that is our memory location, right? So in that memory location, it is serving as a source operand. Destination operand, so whatever the data is stored inside that location will come up into the BX. Okay, an operation is of 16-bit. Why? Because BX is a 16-bit register. BX is internal register and it is a 16-bit register. So the overall operation of this instruction will be 16-bit. Okay, 20-bit physical address of memory location will be calculated. How? Physical address will become equals to segment base address colon effective address. It is the same formula that we stated earlier. And segment base address will come from data segment register, remember, and effective address is equal to, which is directly given in this instruction, is 5062. So physical address will be data segment colon 5062. I hope this thing is clear. Okay, in this slide we are going to introduce with an important concept of assembly language programming in 8086 or 8088 microprocessor, and that is segment override prefix. What is segment override prefix? We have discussed that if we do not mention any segment with ineffective address, so it means we are talking about memory location of data segment. But any segment register can be used instead of data segment, or any segment's memory location can be pointed by the instruction. So for example, we could simply say move bx comma es colon 5062. What is es colon? This es colon thing, look, this es colon thing is basically our segment override prefix. Here if we do not mention this es colon, that means this location will become the part of data segment. But here what we are doing, we are specifying this thing, so that means we are overriding this prefix, or we are overriding a segment over a segment prefix. That means this 5062 location will be part of extra segment. So this time 5062 will be effective address for extra segment, and that memory location will behave as a source, and data content of this location will transfer in this destination operand, which is bx. So through though CS is one of the segment that can be used. Okay, before this point we must look at this thing. Physical address is equal to segment base address colon direct address or effective address. Direct address will be given like this 5062, but segment base can be changed using this segment override prefix, and these four options can be selected: data segment, code segment, state segment, or extra segment. Data segment is used for data storage. State segment again is used for data storage, and extra segment it is also used for data storage. But code segment, why one will be interested to use code segment? Because code segment is storing our code, so that is why this point is written here. Though CS is one of the segment register, but its usage as segment register would be very strange. Why? Because we are not interested in the memory location of instruction. We are interested here in the memory location of data. So CS, using the CS as segment over prefix right, will be very vague. Okay, because we are interested, okay, that thing I have already explained, so I hope you have got the concept of segment prefix override. This is our segment prefix override. Okay, in this slide we are going to deal with an example, and it is also coming from your textbook. So we see here that instruction. I hope you can see it. It is basically move cx comma 1 2 3 4. Let me write, maybe if it is better if I write here move cx comma, and in bracket it is 1 2 3 4. Of course it is in hex. So we see this instruction, and it is basically stored in this location, and it is combination of how many bytes? 4 bytes, because one can actually realize that this location, this location, this location, and this location. So these are basically how many bytes? These are 4 different bytes present inside this assembly language code, because this is assembly language and this is machine code. and 4 bytes of information is stored, and this is pointed by IP and CS. Remember that thing we have already discussed. So IP value is basically 4 times 0, and CS is basically 010. So if you translate these two values, you will receive this location. That is, let me highlight it, this address, which is 0100, and at this address we have very first byte of this information, whatever these 4 bytes are stored. So once this instruction is going to execute, these 4 bytes will execute and IP will point to this location. Furthermore, what this instruction says, this is the memory location, this location. Let me use the pointer, yeah, and this memory location, whatever the value stored here inside that memory location should move to CX. And CX is what? CX is internal register. So we see here that is the content of CX, and that is a don't care. We don't know what is exact value of CX. So it will actually calculate this memory location address first. So there is no segment prefix override is used. So basically it will be what? Data segment. So data segment value is what? 0 to 100. It will be multiplied by 10 and it will become 02000 plus this effective address. Remember, this is direct memory addressing mode, and this effective address is directly given here. So 1234, and once it is got added, so it will become 03234. So this is the location from where we will find certain data. So this location in this memory is displayed here. Look, that is our 0324 location. But wait a minute, we have to move this value to CX register, and CX is what? 16-bit information, but this physical memory contain only 8-bit information. That means the next location, that which is basically this one. So basically that means these 16-bit information will be transferred to what? CX. So this will treat as lower significant byte, and this will treat as higher significant byte. So that becomes BEED. So what will happen after the execution of this instruction? This data will be transferred to here. I hope I have cleared the point. Let me raise and see what happens to the instruction. So now we can see IP has changed its position by 004. That's the new value. That was the value that was supposed to transfer into CX, and we see it is transferred now. So that's how this direct memory addressing will be executed. I hope I have cleared the point. Okay, let's see the second kind of memory operand addressing mode, and that is register indirect addressing mode. What happens in register indirect addressing mode? Last time we were seeing that effective address was given directly as part of instruction, but this time we assume that this effective address of memory operand, which is pointed by the instruction, is present in one of these registers. Either it will be part of base register, so base registers are what? BX or base pointer, or it can be part of index register. So instead providing the direct effective address in the instruction, we are storing that effective address in one of these registers, and then these register will be used in instruction. So indirectly we are providing effective address but with the help of registers. So that is why this is known as register indirect addressing mode. Register. Well, this is the command. This is a normal example of register indirect addressing mode, that is move bx comma cx. Look, we have to deal here very carefully. This is a register. Either is it a memory operand? No, it is not a memory operand. It is simple a register. right, which is counter register or CX register. But what about this? What do you think? Is it a register? If you are thinking since it is BX and so it will be a register, so you are wrong. Because remember, I told you, whenever you see these brackets, this is square brackets, right? Whenever you see this square bracket, that means you are dealing with what? You are dealing with memory. So this is a memory. But what is it? BX. BX is a register. How can a register be a memory? Because BX is providing the effective address, and this bracket tells us that this is a memory operand. So our source operand is CX. That is correct. We don't have any information. But destination operand, which is this operand, is basically memory location, and effective address is content of BX register. So that means indirectly we are giving effective address, but through what register? That is why it is known as register indirect addressing mode, or in total it can be called as register indirect memory operand addressing mode. So operation is 16-bit. Why? Because source register is what? Counter register, which is CX, and it is 16-bit. So this complete operation will be 16-bit. Since no prefix override is used, so segment base address will be what? Data segment. So we will consider that whatever the effective address, it is the part of data segment. So physical address of memory operand will be what? Segment base address colon effective address, and data segment is basically considered as segment base address, but effective address is content of what? BX, so data segment colon BX. So let's suppose if DS is equal to 2000 and BX is equal to 0004. So DS colon BX will be termed as 2004. I hope you can do it. If you don't, let me simply clarify it. 2000 is basically data segment. It will get multiplied by 10, so that will become 200 and 0, and then we have to add the effective address, which is BX, and BX value is 004, so that means we need to add it. So it will become what? It will become 40, and it was a 0, remember. So that means that should be the physical address, and we see it here. I hope that point is clear. So content of memory location, what memory location? 2004 are going to, okay, that is something wrong here. It is supposed to be value of CX register is going to copy inside 2004. Okay, let's take a book example, and in this example we see here instruction is move AX comma SI, which is basically, let me write if it is not clear. I hope it is clear, but I can write it for you. Move AX comma, in bracket we have SI. So that means this is going to be our memory, right? And it is going to be content of SI, which is basically 1 2 3 4, and that is our AX is accumulator, and it is going to be our destination, and its current data is unknown. The physical address of this instruction is pointed by IP and CS value. These values are same, so physical address as we calculated in last example will be same, and this time we see it's a 2-byte information. Let me highlight it. It's a 2-byte information. I hope you can see it. 1 byte and 1 more byte. So if this instruction is going to execute, IP is going to point that location. What's gonna happen? We need to calculate the physical address. Physical address of this memory location. So physical address of memory location, since there is no prefix override, so ds will be used. So ds value is what? 0 to 100. It will multiply by 10, so it will become 0 to 1000 plus 1234. Why 1234? Because effective address is content of SI, and SI's content is what? 1234. So effective address will be value of SI, which is 1234. So once you add them up, it is becoming 03234 hex, and that is the physical address of this memory location. So where we can find this memory location? There, that is that memory location. Look, 0324, and remember that location will have only one value, which is ed, but we need to move it into AX register. That means it is going to be 16 bits, so we have to take the next byte. So these two locations will be used, and BEED will be stored here in AX. So this value BEED will go here after the execution. So let's see what happens once we are going to deal with execution. So we can see here, very first point, IP has switched to this value, so IP has value changed 002, right? That value has come up here, PEED, we can clearly see it. So that means memory operand can be pointed by a register which is specifically source index in this example, or source index in this example. So I hope I have cleared the point. Okay, that's it from this lecture. I hope you have got two more addressing modes, which are basically register indirect and direct addressing mode, and both are part of memory operand addressing mode. If you have any queries, please note them down, and we are going to deal with them in online session. Thank you so much for listening.